Hi everyone, welcome to this video. By the title, you got an idea about in which topic I'm going to discuss about in this video. Okay. Before going to start about prime number, we already go through a program called find factors. Okay. This one I have to show this. Okay. You just have to know how to find factors of a number. If you know this logic only, then you can proceed towards this prime number check. Okay, by help of this factor number, finding the factors of a number, we can define a number is prime or not. How? I can tell you. Okay, let's go through our notepad. The question is, write a Java program to check the given number is prime number or not. So what is a prime number? A prime number is a number greater than 1 that is exactly have two factors, 1 and the number itself. You can just see this. If a number have only two factors, the factors are 1 and the number itself. This number is not divisible by any other number apart from these two. Then it is prime number. If a number can be divided evenly by any other number, it is not prime. Okay, we just have to find if the number is divisible by these two, then we call it is prime. Otherwise, whatever it is not a prime number. Okay, we just have to check the logic. Okay, I already written here a logic to check prime number. We have to take input n, like we have to take input number as an input from our end user. Then if the number is less than or equal to 1, see, if you try to identify -2, okay, in negative we can't verify 1. When we try to find the factor of 1, it is only 1 have only one factor, it is 1. It is not a prime number. If it is a prime number, it must have two factor, 1 and the number itself. 1 have only one factor, it is not a prime number. If you try to find the factor of 0, no, we can't find. Prime numbers always starts from 2. We just have to remember this thing. Prime number always starts from 2. And then third step, check divisibility from 2 to n minus 1, or more efficiently up to root n. Okay, we can see this on a program. Okay, basically here this line means we have to check this number from 2 to n minus 1. If I try to find 13 is a prime number or not, I have to run a for loop from 2 to 12. N minus 1, that means 13 minus 1, 12. I have to check. Okay, we are going to find some shortcut way, like whether we are facing some less number of iteration. Okay, the next step, if the divisible by any number in the range, it's not prime. Okay, that means our for loop starts from 2. Any number is divisible by 1, we know this thing. Any number is divisible by that number itself, that we know. If it is divisible by 2 to n minus 1, we have to, let's define another variable, let's count. If my count is more than 0, that means it is not a prime number. We just have to check if my number is divisible by 2 to n minus 1, it is not a prime number. If my count is equal to 0, then it is a prime number. It is not divisible by any other. You can see this example. Okay. Here number equal to 7. Okay, I just have to highlight this thing. Number equal to 7. What is the factor? In our for loop, we have to run 2 to 6. 7 is not divisible by 2, not by 3, not by 4, and 5 and 6. No, it is not divisible by any of this number, but it is divisible by 1 and 7. We know this thing. That means apart from this 1 and 7, there is no factors of 7 present in this range. It means 7 is a prime number. Whenever we try to check with 12 itself, 12, it is quite different. We know 12 and 1 is there. We already know this thing. We just have to check from 2 to n minus 1. That means whenever a for loop starts with 2, okay, it's check. Yeah, 2 is a factor of 12. My count is already increased by 1. That means it is not a prime number. You can see some prime numbers are there 2, 3, 5, 7, 11, 13, 17, 19. Okay, by this is the overall logic you have to use. So let's represent this whole thing through a code. Okay, we just have to create one file, prime number.java, then one main method. Okay, first of all we have to take input from our end user. Scanner AC equal new scanner of system.in, and one printing statement. Enter the number to check. Fine. One variable called number. Okay. This thing we know. Whenever we have to take input from our user, we do this type of thing. Then we have to declare one for loop. Okay. Before going to for loop, here you can see one thing. What is the logic? My number must be more than 1. If it is equal to 1 or less than 1, then I can't do anything. Okay, so before going to do with for loop anything, we just have to declare one thing. If my num is less than or equal to 1, I just have to print not a prime number, or simply you can say prime number starts from 2. Okay, else whatever condition it is, I can just run one for loop. Int I is equal to 2. We know we are checking this thing from I2 to n minus 1, less than equal to n minus 1, then I plus plus. Done. Then we are checking this number is factor of this or not. We know how to check factor. If it is a factor, we just have to declare here one variable called count. Count equals 0. If it is a factor of this number, then I can just do one thing, count plus plus. Okay, if once it is count plus plus, it doesn't make sense to repeat once again this for loop. Okay, I can just do one thing and just break it. Fine, I break it. Now if the value of count is more than 0, it is not a prime number. If it is equal to 0, then it is a prime number. So I am using one conditional statement. If my value of count is equal to 0, I can just simply print here num concatenate with some printing statement. Num is a prime number, else it is not a prime number. Okay, we are done with this. You can see the logic what I'm using. Okay, first of all we have to declare one variable, and then we have to check whether this is the logic. If my number is less than 1 or equal to 1, it is not a prime number, because prime number always starts from 2. And then if it is more than 1, my controller is going to this else block. Then we are running a for loop from 2 to that number minus 1. Okay, oh sorry, I write n here, it's num. Okay, I'm running this for loop from that number minus 1. Then I'm checking its number is a factor of its number or not by using this for loop. If it is a factor of this number, then I'm going to increase the count of this variable. First of all, for that I have to declare one variable. If my value of count is increased by 1, then I break it. I don't need to run this for loop again and again, because my count is value is already 1. That doesn't make sense to run it. Then by this use of conditional statement, I'm going to verify if the value of count is equal to 0, then it's prime number. If it is 1 or anything else, then it is not a prime number. Let's run this program. First of all, I'm going to check with 1. Okay, prime number starts from 2. Okay, this thing is right, but you can see it's printing 1 is a prime number because the count is already 0. That means we do one mistake here. We just have to put this conditional block here only within this else block. I just have to arrange it properly. Okay, done. Then we have to run it. I have to give input as 1. Prime number starts from 2. It's all right. Then I have to print 2. 2 is a prime number. I can just check with 4. 4 is not a prime number. Whenever you try to find the factor of 4, okay, you can see in this factor program, if I try to check this factor of 4, okay, I'm trying to check this factor of 4. You can see 1, 2, 4. It is more than 1 and 4 are quite fine, but 2 is there. It is not a prime number. It is more than 2. More than 2 factors are there apart from this 1 and that number. You can check any other number. Like if I try to check here, minus 12. Prime number starts from plus 2. We just have to deal with positive number. Okay, this is all about our program. Thank you for this video. Let's meet in our next video.